Hi Ted, hi Larry. This is my latest video. This is back to 24 gigahertz steering. So I've got it's a little easier to see because I've changed the geometry. This is two parallel plate waveguides stacked on top of each other. You can see them here. And there's a fluorescent desk lamp sandwiched in between the two, I guess, three plates uh, comprising two parallel plate waveguides with fluorescent lamps sandwiched in between. So when I turn on a fluorescent lamp, it changes the phase velocity, and the idea is that on the output, this is the output of the apparatus, I can get steering. On the input, this is what's different, and this is pretty cool. This is a microwave 24 gigahertz transmitter for the roadside speed cart that measures your speed as you're driving by, and it has a lens, and that lens makes a pretty narrow beam coming out. So the difference this time is the signal going into my phase shifter is pretty close to a plane wave, and that is making all the difference. So that's the transmitter. This is again my 10 gigahertz horn, which is not very sensitive to 24 gigahertz. That's why I have it closer to the transmitter than I would like it. Now, difference this time is I have a turntable, and this green thing up here is my marker. So, uh, so right now the microwaves are the transmitter's turned on. The receiver, as before, that's a crystal diode receiver, 10 gigahertz, working at 24 gigahertz. It goes up to this receiver, and that's the microwave signal with no current in the plasma. So that's off to the side. That's 15 degrees. That's 0 degrees. That's 15 degrees in the other direction. Okay, so so that's straight through. So Larry, as you asked yesterday, I'm going to turn up the current. Turn up, there's the plasma tube coming on. I'm going to turn up the current. That's 10 milliamps, 20, 60, 100, 150. So the current's not zero. I mean, the microwaves coming through do not go to zero, but it's about a factor of 3 less voltage. Okay, so there is a lowering of the signal straight through with the plasma. Now I'm going to switch the I'm going to tilt the turntable to 15 degrees. Yeah, right there. You can see. And the signal is almost zero. So I'm going to start increasing the current again. This is 0, 30, 60, 80, 100, 150, 150. So again, the signal is going up. So that's the steering. Now, let me show you something else while I'm here. This is straight through the beam. That's 0 degrees basically. So I'm going to go to, instead of 15, I'm going to go to 10 degrees right here. So the signal is lower, but Not that's 15 degrees. This is 10 degrees. Make sure I've got it on 10. Yeah, right there. So again, hasn't gone to zero. We're still on the main lobe. So let me increase the current. That's 0. That's 20, 30, 60. Signal's going up. Almost to where it was before. That's 90, 100, 120. Now, I'm not sure you can see it very clearly, but it actually goes through a peak. Actually, that's not very clear. Let me, that's actually a little more, I have the deflection a little more than 10 degrees. That's right at 10 degrees. So again, we're on the edge of the main lobe as far as signal, and that's 0 current, 60. So it goes up to the original level. And now, between 120 and 150 milliamps, the signal's actually starting to go back down a little bit. And I think that's very important. That's indicating that there's a beam with some beam width. So guys, I think this is demonstrating genuine steering at 24 gigahertz. And obviously what I need to do is I need to clean this up. I need to get a better receiver, or find a better receiver. And I need to do a radiation pattern, which I can do. And let me show you this. This is the transmitter. Yeah, it's got a short horn and a plastic lens. And if I've checked that before, that's a pretty narrow beam width, and I think that makes all the difference, because I think you need a relatively you need a plane wave coming in to the input of the deflector. Otherwise, you get all kinds of reflections. Guys, we'll talk to you later.